Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester is digital communication, and the topic that I discuss today is coherent binary schemes. And in this, we will discuss ASK, means amplitude shift keying, FSK, frequency shift keying, and PSK, phase shift keying. So basically, digital modulation techniques broadly classified into three groups or categorized into three groups or three types. One is ASK, second is FSK, and third is PSK. So these are the three basic digital modulation techniques. Although we have many other modulation techniques, but in broad sense or in broadly, or we have three basic digital modulation techniques: ASK, FSK, and PSK. So digital modulations provide more information capacity and higher data security, quicker system availability with great quality of communication. Hence, digital communication or digital modulation techniques have a greater demand. Why? Because of their capacity to convey large amount of data that as compared with analog modulation techniques, right? So there are many types of digital modulation techniques and also their combinations. So we have to use one at a time depending upon our need. Okay. The first technique that I discussed, we start with this video lecture with first digital modulation scheme, which we called as ASK. In short, we say ASK, and if you elaborate this ASK, it is amplitude shift keying. So amplitude shift keying, ASK, is a type of amplitude modulation which represent the binary data in the form of variation in the amplitude of a signal. Means your binary data is your binary data. According to your binary data, the sinusoidal carrier frequency is modulated, right? According to the binary data. That is why we called as amplitude shift keying, because carrier change its amplitude according to the binary data. So any modulated signal has a high frequency carrier. So the binary signal, when asked modulated, gives a zero value for low input, while it gives carrier output for a high input. Means as far as 1-0 string, because in digital communication you always have information in the form of 1 and 0, and these are 1 and 0 sometimes represent as 0 and 1 volt. So according to 0 and 1 volt, if you look at the picture, this is 0, this is 1, this is 0, this is 1. So when 0 volts come in the picture, this carrier signal have a 0 voltage. Sometimes 0 voltage, sometimes represented as a low voltage. And whenever 1 come in the picture, then carrier has its full amplitude. Look at this amplitude, right? Full amplitude or high amplitude. So whenever 0 come in this binary sequence, there is no signal, because carrier change its amplitude as 0 volt. And whenever 1 come in the picture, then carrier represent full amplitude variations of their amplitude, right? Look at this. So amplitude change and frequency phase remains the constant, because at a time only one parameter is changed, remaining two are constant in a carrier signal. There is another way of describing this ASK signal. So whenever 1 come in the picture, amplitude of the carrier is low. 0 come in the picture, amplitude of the carrier is low. So 1 bit is represented as 0 bit is represented as low amplitude, and 1 bit is represented as high amplitude. So because 0 and 1 change in 2 steps, either 0 to 1 or 1 to 0, then the amplitude of the carrier signal is also changed from low to high, high to low. right? So the stance of the carrier signal is varied to represent binary 1 and 0, and frequency and phase remains the same. So if we summarize this ASK, ASK is the simplest and most common form of ASK, operated as a switch and using the presence of a carrier wave to indicate a binary 1 and its absence to indicate a binary 0. This type of modulation is also called as on-off keying, or sometimes we say OK modulation system, and is used at radio frequencies to transmit Morse code, referred to as a continuous wave operation. Now come to the second digital modulation technique, which we called as a FSK, or frequency shift keying. So what's happened in frequency shift keying? In frequency shift keying, the frequency is the frequency of the carrier is changed according to a binary, or you may say digital signal, or a binary bit, right? So frequency shift keying, FSK, is the digital modulation techniques in which the frequency of the carrier signal varies according to the digital signal changes. So FSK is a scheme of frequency modulation. So the output of a FSK modulated wave is high in frequency for a binary high input and is low in frequency for a binary low input. Means whenever one come in the picture, whenever one come in the binary sequence, the carrier change its frequency as high, and whenever 0 volt or 0 bit come in the picture, the carrier signal change its frequency as low. So the binary 1s and 0 are also called mark and space frequencies. The following image, this is the image that look at this image. So whenever 0 come in the picture, the frequency is minimum, and whenever 1 come in the picture, look at the maximum, because frequency is measured in terms of number of cycles. So the number of cycles is more to represent 1, and number of cycles are less to represent 0 volt or 0 bit, right? So this is another way of describing this. So whenever 0 come in the picture, look at this 0 and this 0, less number of cycles, matlab frequency is minimum, and whenever 1 come in the picture, frequency is high because of large number of cycles, high number of cycles. So this means that this carrier change its frequency low to high, high to low, depends upon 0 to 1 and 1 to 0. So the frequency of the carrier is varied to represent digital data, binary 0 or 1. Peak amplitude and phase remains constant. FSK avoid noise interference by looking at frequencies and ignoring amplitudes. Limitation of FSK is the physical capabilities of the carrier, right? So if you now come to the third digital modulation technique, which we called as a phase shift keying. In short, we say FSK. So phase shift keying, or PSK, is the digital modulation techniques in which the phase of the carrier signal is changed by varying the sine and cosine input at a particular time. So PSK technique is widely used for wireless LANs, biometric, contactless operations, along with RFID and Bluetooth communication, right? So in phase shift keying, the carrier, which is a high frequency analog signal or sine wave signal or cosine wave signal, change its phase as according to the digital your digital signal that is represented by high or low volt, that represent 1 and 0. So according to 1 and 0, the high frequency signal, which you called as a carrier, change its phase depending upon 1 and 0. PSK is of two types depending upon the phases of the signal get shifted. They are binary phase shift keying, which we called as a Bpsk. So this is also called as two-phase PSK or phase reversal keying. So in these techniques, the sine wave carries takes two-phase reversal such as 0 degree and 180 degree. So the phase change again in two step, because the digital signal is also change in two step. There is a transition of 0 to 1 and 1 to 0. So similar way, the carrier, the high frequency signal also have a transition of 0 degree to 180 degree or 180 degree to 0 degree, depends upon the 1 and 0 digital bits or digital signal, right? So here the phase of the high frequency signal is changed according to the 1-0 string of the digital signals, right? So this is the phase shift keying. So following is the diagram that represents this Bpsk modulated output wave along with its given input. Input is always have a binary data that represent 1 and 0. Look at this figure. And this picture is a modulated wave. This is the modulated wave. Sorry. So you clearly seen that when this high voltage to 0 voltage occur, so this is a transition point. Look at this. Look at this. The wave is just disconnected here because of change its phase. And the instead of starting from that point, it start is in that way. Opposite, just opposite. It is a 0 degree and it is 180 degree. So there is a shift of 180 degree here. 0 to 180. Then again with the same phase, again there is a transition line come in the figure where low voltage become high voltage that represent 1. So 1 come in the picture again. Instead of continuation of this analog signal, it is break here, and instead of going downward, it start again in that fashion. So again there is a phase shift. So one phase shift is there, second phase shift is there, depends upon 1 to 0 and 0 to 1. So whenever the binary sequence change from 1 to 0, 0 to 1, there is always a phase shift at that point. So if this is a phase shift at that point, look at this point, look at this point, and this point. So whenever there is a transition of 1 to 0, 0 to 1 in your binary input binary sequence, the modulated wave change its phase, and this wave is a continuous wave. This wave is a high frequency wave, and remember, only phase is changed, amplitude and frequency remains the same, because in digital modulation techniques the carrier change its parameter, only one parameter is changed and other two remains constant. So output sine wave of this modulator will be the direct input carrier or the inverted 180 degree phase shift in input carrier, means either there is 0 degree phase shift or 180 degree phase shift, depend upon 0 and 1. So that this particular this particular picture, this downward, this signal represented modulated wave, or the full form is this particular wave is Bpsk modulated output wave. Bipolar phase shift keying. Bipolar phase shift keying. Bipolar means two. Only two way to shift its phase. Either 0 degree or 180 degree, depends upon 1 and 0. This is another picture that shows the same phenomena, same process, and look at this. So whenever look at this, amplitude remains the same, frequency remains the same, but phase change. So when 0, this is 0 bit, this is a duration time, and when this 0 become 1, this point there is a phase shift. Look at this, 1 remains same for the next load, so there is no change here, there is no change in the phase. When 0 come, then here again there is a change in the phase, right? Here 0 to 1, again there is a phase change. So phase of the carrier is varied to represent digital data, binary 0 or 1, right? So, and amplitude and frequency remains constant, right? So there is a phase change of 0 degree to represent 0, and phase change of 180 degree to represent 1. That is why we call is a bipolar phase shift keying. And Psk is not susceptible to noise degradation that affects Ask or bandwidth limitation of FSK. So whenever we have a 0 bit, we have a 0 phase, a 0 degree phase shift. Whenever we have a 1, we have a 180 phase shift. You can also understand this process from here. And so thank you very much. So this particular video lecture is on digital modulation techniques, and in that lecture we had discussed ASK, FSK and Psk. So thank you very much.